Welcome back to my channel. So as we have discussed in the previous videos, what are the main components of the CNN, and we figured out that activation function is one of the main, let's say, components. So imagine your brain is decided, let's say, to select whether to react or to stay quiet. That's what activation function do in a neural network. They decided whether a neuron should fire or not based on the input signal. And as you can see here, each output, let's see, this is for instance a hidden layer here. This is the hidden layer. I'm just trying to lock all of these. So let me, oops. So when I click, I will, okay. So each hidden layer after this is, let's see, the input, and this is the hidden layer. And after calculating the summation of the multiple of the linear regression, this equation of the linear regression, now we have the activation function, and the activation function is after applying the activation function to this value here and to the output. So if in case if we have a sigmoid function, let's say binary classification, we will use sigmoid function. So our first guess is a sigmoid function. It takes any number of, it could be a negative or zero or huge number, and squeeze it into a range between 0 and 1. So why we need it to between 0 and 1? See, it's like when you have values between 0 and 1,000, it's hard to interpret it. And when you have it, if you squeeze it into between 0 and 1, you can it's easy to interpretate this. So it's like it will be as a confidence score or probability or maybe binary decision. So it turns the signals into how likely values, for instance, between 0 and 1. And let's have a look. This is in this feature map here. So the raw values, this is for instance the input image, this is the filter, and this is after convolution. This is a feature map. And after the feature map, we have the activation function. So as you can see here, the raw output from the convolutional layer, this is number can be range between 0 and 15, from 0 and the maximum one is 15. And it's like messy. It's not easy, let's say, to interpret, right? Now see, we apply sigmoid function. This I have applied a sigmoid function to every number in the future map, one by one. It's a pairwise, so it's just taking the 5 and replace it with x and calculate the activation function for this pixel, for this output, and do it for this and for the whole matrix. Let's see. And for instance, 5 will becomes 0.993 and etc. So if you can see here the transformed function, think of it like a heat map of the confidence. A lighter means lower activation, and the height value, it's a strong signal. This is and every value is now normalized, making it easier for the next layer to work. So when you normalize the normally in a neural network, it's not we normalize the input images like it's not let's say we didn't input as a numerical from 0 to 20 220 255. So it's like uh, normalize this between 0 and 1, so it will be easier for the calculation. So, and you can see here, this is a simple table that show several activation functions, and I will start with this. When you should use a sigmoid, use sigmoid when you wanted to express something in terms of how sure are we. So it's perfect for binary classification. So assume you have two binary classification, two classes, and you would like to see which one is to select. So the probability or using a sigmoid function is better. It's better to use it in this case. And Yeah, and for the attention, it's also use attention, but it's carefully tried not to use this. Let's see, in a hidden layers. So avoid to use in the hidden layers, and it's only used. It's better to use it in a classification for binary classification. Why we can't use it in a hidden layer? Because it's vanishing, it's gradient. So the value of this, the output of this might be close to zero, and if it's close to zero, it won't be. Let's say it will somehow freeze or stop the not stop but freezing the learning because it's almost zero, right? And the leaky is so we use in the hidden layers we use a ReLU function, which is just taking the max, so it's only taking the positive values. Any negative values will be ignored. It will be replaced by zero. And in this, the advantage of this, so some let's see many neurons. Let's say, for instance, many values here. This is a features map. It will be sometimes it will be let's see zero inactive and etc. And why we need indeed the activation function. This could be an interview question because it's adding non linearity to the network. So if we have no, let's see, if we ignore the activation function, the deep learning, the neural network will act exactly the same as the linear regression algorithm. And I will just have this. It's a short, let's see a short code how to apply this because this sigmoid function is already implemented in, let's see, you can just use it in the from torch by torch. It's by importing neural network, and you can see this is a sigmoid function. Yeah, I think that's enough. And for the next, I will try to implement all of these components in one project. If you like this video, please subscribe into my channel, like the video, and if you have a question, please drop it down in the comment below. I will answer it. Thanks for watching and see you next time.